Sixth grade, Module 6, Lesson 13 problem set. Number 1. The average monthly high temperatures in degrees Fahrenheit for St. Louis and San Francisco are given in the table below. A. How do you think the data might have been collected? So we have the data from every month, and it is the monthly high temperatures. So in January, the high temperature was 40. In February, it was 45, 50. July, we're up to 89. Versus San Francisco, we have 57, gets up to like 70 in September. So how might the data have been collected? Well, I mean, maybe someone sat outside and took the temperature every hour of every day and then collected it and found the mean, because it's the average monthly temp. So I guess someone or some machine or something was taking snapshots of the weather every single day and coming up with what the average was. So maybe someone recorded the temperature. Just say temp was recorded every hour of every day. And then the averages are taken, or the average is found. So if you have another theory about how that data was collected, go ahead and write it down. There's not really a right or wrong answer there. Okay, B, do you think it would be possible for a fourth of the temperatures in the month of July for St. Louis to be 95 or above? Why or why not? So it's saying in July, the average temperature was 89 degrees. So that means that some temperatures were more, some were less. It just depended on the day. So I would say that, yeah, it is possible that a fourth of the temperatures for the month of July could be 95 or higher, because maybe this is like a fourth, and then another fourth could be 95 or higher, which would average out to about 89 degrees. So it's definitely possible. So let's just say yes, because there are 31 days in July, and if 1/4 of them were, does it say 95 degrees or greater, that means that 3/4 were less than 95 degrees. So the mean could average out to 85 degrees. So it is possible. You could make a list, like maybe it was 100 degrees for 3 days and like 86 for the rest of the days. That might average out to 89 or 85. So it's definitely possible. All right. C, make a prediction about how the values of the IQR for the temperatures of each city compare. Explain your thinking. Okay, so what I'm noticing here is that St. Louis ranges anywhere from 40 degrees, there's a couple 43s, all the way up to 89 and 85, whereas San Francisco is more mild. We've looked a lot of San Francisco temperatures in the past unit here, and so we have 57, 62, 67, 70. It's all like not very spread out. So I would say that the IQR, St. Louis is going to have a much greater IQR than San Francisco, because the temperatures vary a lot more. So let's say, how do we want to word this? Let's say San Francisco, let me change colors so we don't get confused. San Francisco probably has a smaller IQR because the temperatures don't vary as much as St. Louis. And find the IQR for the average monthly high temperature for each city. How do the results compare to what you predicted? So now we actually have to find the IQR. So to start out, what I'm going to do is I'm going to list them in order, both of them in order, from least to greatest. And I will be back after I've done that. Okay, so I've listed them in order from least to greatest for St. Louis and San Francisco. So let's start by finding the median of St. Louis. So I'm just going to cross out until I find the middle. So we are left with 67 and 69. So what's in the middle would be 68. So the median is 68. Now I'm going to find the IQR by finding the median of the bottom half and then the median of the upper half. So we'll use green. I'm just going to cross the other way. So we're left with 45 and 55. Median of that would be 50. So here's Q1 would be here. Q2 is between 50 and 67 or 68. So let's find the median of the upper half. It would be in between 81 and 85, which would be 84. So to find the IQR, we need to do 84 minus 50. Oh, I'm sorry. 84 is not in the middle of 81 and 85. 83 is. I knew that didn't look right. Okay. 83 minus 50 would be 33. So the IQR is 33 for St. Louis, which is pretty big. That's a pretty big spread there. So let's do the same thing for San Francisco. Find the median. So it's going to be right here in the middle of 63 and 64, so 63 and a half. And now let's find the IQR. It's in the middle of 60 and 62, so 61. And then in between 67 and 68, so 67 and a half. So let's do 67 and a half minus 61 would be 6 and a half is the IQR for San Francisco. So we were correct. The IQR is much smaller for San Francisco than 33, right? So let's just say we were correct. San Francisco has a much smaller IQR, 6.5, than St. Louis, which was 33. Number 2, the plot below shows the years in which each of 100 pennies were made. A, what does the stack of 17 dots at 2012 representing 17 pennies tell you about the age of those pennies in 2014? So 17 dots at 2012. Let's go ahead and find that right here. So there's 17 dots in 2012. What's the age of those pennies in 2014? So if they were made in 2012, then in 2014, they would be 2 years old. B, here's some information about the sample of 100 pennies. The mean year they were made is 1994. The first year any of the pennies were made was 1958. The newest pennies were made in 2012. Q1 is 1984. The median is 1994, and Q3 is 2006. The MAD is 11 and a half years. Use the information to indicate the years in which the middle half of the pennies was made. Okay, that was a lot of information, so let's kind of break it down. Let's first figure out what they're asking. Indicate in which years the middle half of the pennies was made. We want to know which years the middle half of the pennies was made. So I'm going to use the Q1 info and Q3 info because that's helping me split it up into quarters, which is going to help me find the middle half. So Q1 was 1984. Let's find that. There's 1985, so 1984 is about right there. And then, so here's Q1. And then Q3 is 2006. Right here. So there's Q3. So then anything over here is Q4. And the median, that's the middle, right? The median, does it tell us the median? Yep, the median is 1994. So right here. So that helps us split it into the fourths. So we have Q1, Q2, Q3, and Q4. So the middle half would be in the middle here, anywhere from 1984 to 2006. Let's say it's from 1984 to 2006, and let's find out how many years that is. Nope, 10 minus 8 is 2. 0, 0, so that is 22 years old. Or not years old, just 22 years is when the middle half of the pennies were made. Number 3, in each of parts A through C, create a data set with at least 6 values such that it has the following properties. A small IQR and a big range. So we want a small IQR, so not much is changing, but a big range. So what we can do to find a small IQR, but a big range, I'm just going to start with 0 and 100. And then we need at least 6. So I'm just going to put a bunch of 50s in there. So our range is big. It's 0 to 100. So the range is 100. But the IQR is going to be 0 because, well, we can find it. So let's see. The range is right here. But the IQR is going to be 50 minus 50, which is 0. So it has an IQR of 0, but a range of 100 minus 0 of 100. So large range, small IQR. B, an IQR equal to the range. So here, we don't want the IQR to necessarily be 0, unless we have a 0 range, which, so let's do 10, 10, 10, 15, 20, 20, and 20. So here our range is 10. And then since we have 10s down here and 20s up here, when we subtract those, we're going to get 10. So the range will be 10, the IQR will be 10. Part C, if we want the lower quartile to be the same as the median, then let's just make it be the same number. So make the first half, including the median, all the same number. So maybe I'll make them all 2s. Let's try 2, 2, 2. If I want 7 numbers, 2, and then I can just add whatever I want, 3 more numbers, 3, 4, 5. So now if I were to find the median is right here, and then the lower quartile here is also all 2s. All right, number 4, rank the following 3 data sets by the value of the IQR. So we need to find the value of the IQRs and then rank them. So first thing we need to do, and what I'm going to do, is list out all of the data in order from least to greatest. So I will come back after I have listed all of those out, and you can go ahead and do the same. All right, I've listed everything out here, so let's find the median for the first one, which is called data set 1, 2, and 3. I'm going to cross out 2 at a time to start. 2, 1, 2, 1, 2. Okay, so here's our median is 10. So let's find the upper quartile median, or the upper medium and the lower median. Use a different color. 1, 2, 2. So in between 5 and 10, that would be 7.5. And then the upper part, let's cross out 2. Is 20. We have 2 20s, so 20 and 20. And then if we subtract 20 minus 7.5, we get 12.5 as our IQR for data set 1. Let's go ahead and highlight it so we remember. Let's go ahead and find data set 2. Let's do 3 at a time. 1, 2, 3. 1, 2, 3. When I get closer, maybe I'll just do 2. Down to 1. So we're here in between 65 and 70, which would be 65 and 70, 67 and a half. So now let's find the upper and lower. Use blue, so 2. So we have 55 and 75. So let's do 75 minus 55. That is equal to 20. So 20 is the IQR for data set 2. And let's do the last one. Find the median. Is 140. So now let's find the upper and lowers. So we have 110 and 145. So 145 minus 110 equals 35. So if we were to rank the data sets from, it doesn't really say how to rank it, does it? Just rank them by the value of the IQR. So maybe we could do lowest, highest to lowest, or lowest to highest. Doesn't really tell us how to do it. So the lowest is data set 1. Oh. Data set 1. Middle, will be data set 2, and highest is data set 3. All right, number 5. Here are the number of French fries in each of the bags from restaurant A. Okay, so we are back to these French fries. Suppose one bag of fries had been overlooked and that bag only had 50 fries. If that value is added to the data set, would the IQR change? Explain your reasoning. So I'm going to list them, and then I'm going to do it with the 50 and without the 50 to see if the data set changes. All right, I have written out 2 different data sets. I did one without the 50 fries and one with the 50 fries. So the first one, let's find the IQR without 50 fries and then with, and we can compare them to see if it changes. Okay, so start by finding the median. I'm going to do 3 on each side, just working my way towards the middle. I'm just going to do 1 until I reach the middle. So here's the middle in between 80 and 84, so that's 82. Now let's find the quartile 1 and quartile 3. So find the median of the upper and the lower. Okay, so here would be 77. Now let's find the median of the upper quartile, or the upper half. Be 87 and a half is between 87 and 88. So 87 and a half minus 77 would give us 10 and a half. So now let's do with 50 and see what we get. So find the median again. So here the median is 80. So now let's find the IQR of the upper half, or lower half. So in between 73 and 77 would be, let's see, 75. And then over here, between 87 and 88, be 87 and a half. So let's do 87 and a half minus 75. We get 12 and a half. So the IQR does change. It goes from 10 and a half to 12 and a half because it goes up by 2 because look, the median also changes by 2. So the IQR is larger because the median number is now 80 instead of 82, which then changed the lower half from 77 to 75. So let's say we're still on A. I'm going to clarify we're answering A. The IQR is larger, 12 and a half, because the median number of fries is at 80 instead of 82, which makes the lower quartile $75 instead of $77. B, will adding another data value always change the IQR? Give an example to support your answer. So no, it's not always going to change your IQR. It depends on several different factors. So let's say no, it depends on how many values you have, and what values are added into the data. So let's make an example. If we have the data set, let's see, 2, 2, 2, 6, 9, 9, 9. Let me fix those nines. The IQR is, let's see, here's the median, 6. Your upper quartile is going to be 2, lower 9, and if you do 9 minus 2, you get 7. And if you added another 6, so say we added a 6 and made it 2, 2, 2, 6, 6, 9, 9, 9, it's going to also stay the same because your median is still going to be 6, and then your lower quartile is going to be right here. It'll be 2, 9, and 9 minus 2 is still 7. So it can stay the same, or like we saw up here, it can also change.